Good thing we didn't get all the bad choices we made up. So, depending on which way is bigger, that's how you know which way your major and your minor axis are. Your foci over here would be like vertical now, because your major axis would be going vertical. Your center is going to be where those intersect. The distance from the center to a focus is C. The distance from the center to the point on the minor axis is B. And then we're going to talk about A is actually that you can do from here to here, but in this lovely little triangle, you can say that that makes that hypotenuse of that triangle A, which means that if you know two of the three, A, B, or C, you can find the missing one by doing Pythagorean theorem. But A is always the bigger one, so you have to remember this, that it's A squared equals B squared plus B squared, which is a little bit different than normally we think C would be. So I have a lot of, again, formulas for you, but again, we're just going to focus on understanding how to use them as opposed to memorizing them all. So we're going to fill a little bit on here, and then with the HK stuff, we're just not going to do as much. So again, I start with the centers at the origin because it's a little less overwhelming than throwing H and K in there. So if your center's at the origin, your equation is x squared over a squared plus y squared over b squared equals 1. So you can kind of see it's similar to a circle in that x squared plus y squared equals r squared would be like the circle, but because the major and the minor axis are different lengths, that's why they're divided by a number. In a circle, a and b would both equal the same thing. So if a squared is under x squared, then you're going to have a horizontal ellipse like this. And if y squared is over the bigger number, because a is always bigger, you're going to have a vertical ellipse. So I always say the major axis because the Algebra 2 book that I used to teach out of, when we did conics in Algebra 2, called it the major axis, but focal axis is the same thing. Your foci are C units from the center, and so since the center on these are 0, 0, your foci are just going to be C units left or right if it's horizontal, C units up or down if it's vertical. The length of your major axis from the center to the major axis is A units. So if you go all the way across, then the length of your major axis will always be 2A, and the minor axis from the center to the point is B, so altogether that would be 2B units. And the vertices, I don't ever really think of them, but the book talks about the vertices, so I added it. The vertices are the endpoints of the major axis, or the focal axis. And so again, that's just going to be where A is. So that's just going to be plus or minus A0, or 0 plus or minus A, depending on which way it opens. So I'm going to put endpoints of focal. And instead of waiting till tomorrow to give you the HK stuff, I went ahead and put it. I didn't put it for you to fill in, because again, I don't want you to feel like, oh my gosh, how am I ever going to memorize HK to HC? But just remember that it always starts from the center. So if you know where your center is, then you can still move C units this way or A units this way. So notice, just like with everything else we've done, right, this looks a little scary. But if the center is somewhere besides 0, 0, you just have that x minus h squared, y minus k squared. Again, you're still going to know that A is the bigger number. So if A is under x, it's going to be longer horizontally. If A is under y, it's going to be longer vertically. And your focal axis will be through that value in your center, which we're just going to kind of practice doing. But notice the 2A and the 2B still are the same. To me, this was like last year when we did this for the first time and I knew we couldn't use a formula sheet. This kind of overwhelmed me, and I was like, how am I going to keep that straight? But again, just like with parabolas, I'm not focusing on this. We're just going to start with our center, and we know that we'll move C units left and right if it's horizontal. will move C units up and down if it's vertical. And again, even when they don't ask me to graph it, sometimes getting it graphed is helpful. Okay? So let's just see if we can get through some of these now that we wasted too much time on those interventions. Find the vertices and the foci of the ellipse and then sketch the graph. And so at some point in here, we're going to talk about how can you tell if it's an ellipse or a circle or whatever by looking at it. Well, this is definitely not a parabola because both x squared and y squared are squared. If we want to put this in standard form on an ellipse, we have to have it equal to 1. So we're going to divide everything by 12 here, because I need this to equal 1. And so you're going to see that's where your fractions will come in. So that's going to give me x squared over 4 plus y squared over 3 equals 1. So you can't use those formulas if you don't have the equation set equal to 1. Questions about that? So just looking at this, these are some things we should be able to say. Because there's nothing added and subtracted on the top, right? This is going to be the one where the center is at 0, 0. Should this one be longer horizontally or vertically? Horizontally, because 4 is bigger than 3. Yes? So this is a squared, and this is b squared. So I know here that a equals 2, and b equals the square root of 3. That's true. So they asked me for the vertices and the foci, which means I'm going to have to find C at some point. But if we were going to graph it, I want to show you that if you were going to graph it, all you need is the center, and you need A and B, and that's all you need. So, my center is at 0, 0. You got to know which way to go, but since A is under X, that means I'm going to go A units left and right. So since A is 2, that means I'm going to go 2 over here and 2 over here. Those are going to be my vertices because they're on the focal axis. Kind of ugly when it's a square root of 3, but square root of 3 is like, what, 1.4, 1.7? I don't know, 1 point something. So square root of 3 is going to go the other way. So I'm going to go up 1 point something and down 1 point something. And that is a sketch of your ellipse. It's really close to a circle. Do you agree with that? Because the A and the B are pretty close together at being the same value. If I want you to give me the vertices are A units left and right, which we can just look at this and say that my vertices are, what, negative 2, 0, and 2, 0. So it's the same thing. I'm just going to say plus or minus 2, 0. But to find my foci, I have to find C, and that's where you have to know the ratio or the relationship between A, B, and C. You have to know that A squared equals B squared plus C squared. So that's going to be 4. I'm going to go ahead and subtract 3. Because that means that C just equals plus or minus 1. Which means you can see on this that your foci, which you don't have to graph, but those would be your foci in this. Not required for us to graph these on here, but we're just going to say plus or minus 1. A lot of times, if your A and your B are really nice numbers, your C isn't going to be. In this case, B wasn't nice, but C was. How do you feel about that? Overjoyed? Which way is this one going to be bigger? Long ways or bigger vertical? Long way, horizontally, right? Because 64 is bigger than 36. So again, I know it should go this way. Looking at this, A and B I should be able to find, right? This is A squared, so that just means A is 8, B is 6. The center on this one is 0, 0 again, because there's nothing on top. Which means if it just graph it, right? Like that's the best it can get. If I'm just going to graph this at 0, 0, you just got to make sure you go the right way. So we're going to go 8 units on either side, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's where you get the 2A from. And 6 units up and down. And again, it's kind of circular because A and B are not that far apart. Think about if B was like 4, it would look a lot. Today we're really focusing more on graphing and pulling information out. Tomorrow we'll work on writing our own equations. But let's do one with the center not at 0, 0. What about on this one? Is it going to be bigger horizontally or vertically? Because it doesn't necessarily mean y has to be first. It just means the number under y is going to be bigger, right? So this one, I just always write it for these things. B equals 7, A equals 3. What's my center on this one? Negative 2, 5. So again, I don't worry about those formulas. I just start at my center, and then I move left and right. I screwed that up. I would have drawn it the same way, but that's really B and that's C. That's A. I would have dressed it right. I just labeled it. But I'm going to move up and down 7, left and right 3. But the difference is I'm going to start at negative 2, 5. So at negative 2, 1, 2, 3, 4, 5, that's going to be my center. So 1, 2, 3, 4, 5, 6, 7. I'm going to go a little bit off the graph. 1, 2, 3, 4, 5, 6, 7. And then I'm just going to go left and right 3 units. Roughly like that. Questions on graphing? One more. Alright, so the last thing is, again, just like with circles and just like with parabolas, you want to be able to take this is what we call general form, and we want to be able to put it in standard form so that we can graph it. So just like with circles, you might have to complete the square with both x and y. Remember, what's different than circles is we're going to have it equal to 1 on the other side at some point. So I'm just going to rearrange mine. So I have 9x squared plus 36x plus 4y squared minus 24y, and then throw that negative 36 to the other side. Remember that you can't complete the square unless you factor out that number in front of x squared and y squared. I always just factor it out and then divide it in. If you're going to divide first, you have to divide everything in that problem by 36, which is not going to be good right now. So this is where you're going to want to factor. So like I would factor the 9 out of here, and then that would be x squared plus 4x, and then I can complete the square. And I could factor the 4 out of here and get y squared minus 6y. But then don't forget, when you do it to the other side, you have to multiply that number in front. So hopefully we feel pretty good about half that middle number and squaring it. So half of 4 is 2, and 2 squared is 4. But remember, I'm not just adding 4 over here, I'm adding 4 times 9. So I'm actually adding 36. Half of negative 6 is negative 3. Squared is 9. And again, 9 times 4, I'm actually adding 36 over here. So then remember it's half of that middle number. So on this one that's plus 4x, we do plus. And then half of negative 6 is minus 3. And then I think we just get 36 over here. A lot of 36s. And what's the last step going to be? Yeah, we want this to equal 1. So we're going to divide everything by 36, which is where we're going to get our A and our B from. So we're going to get x plus 2 squared over 4 plus y minus 3 squared over 9 equals 1. So actually it turns out that this will be a vertical one and not a horizontal. And then tomorrow we'll go in, like if I give you some information, can you write equations, and maybe we'll talk about substitution. So you're just doing 1, 6, 11, 15, 18. And I have graph paper if you prefer graph paper, or you can just grab something.